We go. Off we go. Right. Question number 24, please. Ikra, join us and read the question first, please.
OACB is a parallelogram. O to A equals A and O to B equals B. D is a point such that A to C equals C to D. The point N divides O to B in the ratio 2 to 1. Write an expression for O to N in terms of A to B.
Lovely. So, what are the key words in this question, first of all?
It's a parallelogram.
Okay, so what do you mean by parallelogram? So that means what can we assume, or what can we add to the diagram?
So that the opposite sides are equal to each other.
That's right. So the bottom vector is B, and the top vector A to C is also B, because in a parallelogram the opposite, those parallel sides are equal. Okay, and A is going up, and there's another A going up on the other length, which is C to B, because the length C to B equals A to C and is at the same angle, so it is also can be represented by the same vector. Okay, lovely. Right, so we label that now. It's given us something here. What does this mean here?
So it's basically saying that A to B is the same as C to D.
So what is this vector here then?
It's going to be B then.
It's going to be B. Okay, so that's important. So you got to read all the information and start labeling and putting extra information onto the diagram. Now, he wants you to work out O to N. So he wants us to go from here to here. Now, do you know how to go to that directly?
We can't go to that directly.
Okay, so which way should we go then? Give me a route, please. Now, I think for this question, I think one little bit's missing, but you'll find that in a second. So can you give me a route, please, and I'll highlight it.
Would we go from O to A to N?
So you want to go O to A and then A to N. That's lovely. I like that route. Let's write that down. So O to N is equal to O to A, first of all, the scenic route, plus A to N. Lovely. Now, they have also given us a ratio as well. It says the point N divides AB in the ratio of 2 to 1. So how do we interpret that ratio 2 to 1? What does that mean?
So it's going to be out of 3 parts.
Lovely. So 2 out of 1 is 3 parts. So each bit's going to be talking in terms of what?
Thirds.
Thirds. Okay. So the first part here is going to be how many thirds?
That's going to be 2/3.
So 2/3 of A, B.
Yeah.
Yeah, and this bottom one will be what?
1/3 AB.
Fantastic, lovely. Okay, let's start putting some more layers of the maths on there. So what is O to A then?
It's going to be A.
And what's going to be A to N then?
That's going to be 2/3 of A to B.
Okay, lovely. Now, do we know what A to B is at the moment?
No.
So let's go and work out. Let's just go over here, come up here. So how would you work out A to B then?
You'd go O to A and then O to B.
So A to O plus O to B. What's A to O?
That would be minus A.
Because you're going the opposite direction of A, and then O to B. What will that be? Fantastic. So we need to do a little bit sometime. We haven't done this before in the question. We need a little bit of thinking and go back and work out some other part of the question. So let me just tidy up all this because it's looking a little bit messy. Let's get rid of all this extra stuff. Let's get back to our original. Okay, lovely. So we're still working on the green part. So we got plus 2/3 of A to N. So it'll be A, add 2/3 of what's A to B?
Minus A plus B.
Lovely. So what will that equal to now?
That would be A plus minus 2/3 A plus 2/3.
Okay, can you simplify that for me, please?
And then A would just be 3 over 3.
So A is 3/3. 3/3 A minus 2/3 A gives us what?
That gives us 1/3 A.
Okay, now can you factorize that for me?
And that would give you a third and then brackets A plus 2B.
Fantastic, lovely. So that's given us O to N now. What we've done over here, remember, we've done this extra bit over here. So I'm going to put that into this kind of, this orange colored cloud over here. So we had to kind of go and work out that. Let's get rid of these. So sometimes you don't always have everything already worked out. In the previous question, we just went to the previous part of the question and we just reused that. At the moment, in this question was the first one we done where we couldn't do that. So you got to be aware of that as well. Okay, next. So it says prove that O to N to D. So let's have a look now. So what part of the diagram are they talking about? So they want to go from O to, oops, yeah, wow, it's landed on top of it. Amazing. So we've got O to N. Okay, I really want that line to be a little bit above. Yeah, that's better. Okay, I'll put it above on purpose because I want to show them as separate lines. But you can see that that pink line is really supposed to be O to D, but I'll put it on purpose a little bit ahead so it's kind of not matching exactly. So yes. So what line do we need to do now to prove O and D is a straight line? What's the next part of our proof? We need to work out O to D because we've just worked out O to N. We've got to work out O to D. So O to D is what we need. So how would you go from O to D? Look at the diagram. It's quite easy actually.
You would just go O to A and then A to D.
Or A to C and then C to D, yeah?
Mm-hmm.
Okay, lovely. Let me get rid of these extra lines over here because they're a little bit confusing. Okay, what's O to A? So your route is going to be this way and that way. Is that right?
Yeah.
Okay, so give me the first part of the route. What's O to A?
That's going to be A.
And what's A to C?
That's going to be B.
And what's C to D?
B again.
So can you simplify that for me, please?
That's going to be A plus 2B.
Okay, that's very good. Now I want you to carefully look at this one. I'm going to highlight for you. Look at this and look at this. So what do you realize straight away about those two vectors, O to N and O to D? What do you realize?
That they're multiples of each other.
So what does that mean?
That means that they're parallel to each other.
Fantastic. Now we got to go from what you've just discovered to the last bit that they're on a straight line. So let's just do a little bit of labeling. That's O to D. So what do we say? Let's look at our sentence now. So we say O to D is parallel to O to N. Why is it parallel to O to N, first of all?
Because they're multiples of each other.
Okay, because it is a multiple of it. Okay, are you happy with the first part of the explanation?
Yeah.
Now, in the question, they haven't indicated that we need to do this, but we do need to do this. They said to prove that something is a straight line. But this is our sense. This is the foundation of that explanation. Is what we've done in the previous questions. Now we're going to add on the extra layer. So what do we notice about these two vectors? Where did they both start from? Oh, exactly. Okay, so O to D and O to N have a so O to D and O to N have a common starting point O. So both vectors start from the same place and they're parallel. What does that indicate that they are? If you have two parallel vectors starting from the same place, does that mean they are physically on top of each other? That's why I moved the look here. If I grab the line and move it back, there you go. I grab the line, move it up again. Yeah, yeah. So O to D and O to N have a common starting point O. Therefore, O and D is collinear. So O and D is collinear. I.e. O, N, and D are on a straight line. Okay, done. So that was the extra layer that we needed to add. Number one, we had to prove that those two components are parallel. Number two, we have to say because they have a common starting point, that means O and D are collinear. Okay, O and D. So O and D are collinear. So we talk about the points O, N, and D. Okay, so it says O and D is a straight line. Okay, done. Are we happy with that?
Yeah.
So we could. So it's O, N, and D. Just make that a little bit more tidy. O, N, and D. Are collinear. O and D are on a straight line. Fantastic, done. So that question has a different style to it a little bit because we had to prove that something is a straight line. And that's the end of that question.